Hello Lokya, hello Panori. Oh, we haven't finished this question. Huh? Okay, okay. One more question. Wait. Separated by distance. Requirement. Placed near a long line charge. Density 4 × 10⁻⁻4 centimeter inverse. As shown in figure. Negative charge. Distance of 2 centimeter from line charge. Calculate acting dipole. Dipole means it has equal and opposite charges. This is line charge. Okay, try this. Yes, guys, what we'll do here? Any idea? It's a line chart. That means if you remember, charge density per unit length. So that lambda formula will use. So I'll give you formula. You try it again. What was that formula? Lambda something. 2 pi, no? Yeah. Yes, so it was lambda by 2 pi epsilon naught r. So we have to find force, okay. It's not just charge, not electric field. We have to find force also. After finding force, we need to do first find E1, then F1 equals to Q E1. E2, then Q F1, F2 equals to Q E2. Come on. Anuri, are you trying? What about Lokya?
Yes, sir.
And Rituraj?
Yes, sir, I'm trying.
Okay. You guys know what is epsilon value? Don't make this calculation complicated. Make it easier. 7.2 and 6.6. Okay, here 7.2 is correct. Yes, guys, let me check. Yeah, it is correct. You guys are not using any calculator or something, right? I hope not. Very good. Now we need here net force. So what we'll do?
F1 minus F2.
I'm sorry, second.
F1 minus F2.
Yeah. Which one is higher? 7.2 is higher, right?
Yes.
Yeah. F1 minus F2. Even F2 minus F1 if you do negative force. So obviously it will be opposite direction. Yeah. So F1 minus F2 only. It's not just 6 point something. What about Bhanuri? Are you there?
Yes, sir.
Nice. Okay, need any help here? Okay, so for E1,
No,
lambda,
sir.
okay, no. E1 lambda value is Q1 4 into 10 to power minus 2. No, minus 4 centimeter. Into 0.02 distance into 9 into 10 to power 9 into 2 because it's 2 here, so multiply by 2 here, so it will become common. With this one, you can find out the answer for E1, so multiply by charge. 6.4 correct. So charge 2 into 10 to power 8 given into this value. Same goes for E2. 4 into 10 to power minus 4 divided by 0.022 2 mm into 9 into 10 to power 9 into 2. Same, again multiply by charge. Find this one, take this value. Charge is 2 into 10 to power minus 8 into this value. That will be your F2. Point 0.8. No, 0.6. Yeah, F1 minus F2 only. So F1 is 7.2 minus 6.54, something 4 or 5. Yeah, your answer is 6.4. So according to your answer, it will be 0.8 only, but no problem. Banuri, what about you?
Yes, sir.
You got this too?
Yes, sir.
Don't feel shy if you're not getting. If you got, means good.
Okay, sir.
If you don't got, then also okay. Then you have to learn.
Okay. Yeah. This is.
Chalo. Then we'll go for, shall we go next question? Let me see for a question. Distribution of square research. This also I'll give you as a worksheet. Yeah, tomorrow and day after tomorrow, I won't be able to take class. I'll be traveling. So I'll take one. And like, you guys got some summer holidays when it's just starting? Your summer holidays?
They're expecting May 15th, sir.
Okay, May 15. What about others? Same and around?
Starting from day after tomorrow, sir.
Day after tomorrow.
Yeah.
Okay.
From May 10th, sir.
May 10, 15 tomorrow. What about Rituraj? Sure. No, like why I'm asking, like if it is like if you guys have holidays, then I can take class in morning itself. Okay, now let's our important topic for this chapter, that is electric flux. Now, let's understand simple words first. Electric flux means if we take some area, suppose, let me draw some area. Okay, there's an area. From that, electric field are passing. So number of field lines passing through that area. So whenever, if you remember, you're studied in like 10th standard also, electromagnetic induction. Okay, so I'll give you like overall combinedly idea of this one. So whenever field line passing through it, through that area, there will be a fluctuation in magnetic field. So that fluctuation in magnetic field will create or will induce the current. And induced current will generate, or induced current means it is in flux. When it's flux generated, first of all, flux generated, then flux is generated, that means induced current. Current induced means current is generated there due to change in magnetic field. Flux is generated means EMF is also generated. So same way we used to make a generator. We are using generator as this. We are making a coil. We are coil passing through a galvanometer and one coil without that. So there will be one connected with battery, and if battery is connected, current is flowing here. Due to this, there is a induced current in this one. There will be some fluctuation in this galvanometer, which shows there is a current in this one. It was mutual induction. We have one chapter for that, but I'm just giving you idea of it. What is the use of this flux? So simple words we can write here. Flux is what? A number of electric field lines passing through the surface. It is the number of field lines passing through the surface. So if I want to increase the field lines, what will I do? Or if I, sorry, not field lines, if I want to increase the flux, what will I do? Either I should increase the number of field lines or I should increase the area. More the area connected, more the flux generated. So let's write some more points about it. That will be easy for you to understand. Okay. What else we can write here? Let's write some important points about this. Just like the surface. Surface is not open and encloses some net charge. So therefore, total charge within surface is proportional to net number of lines that go through that surface. Surface. So with this we can say phi. Electric flux is denoted by phi. Phi equals to E. Now I have drawn this one a straight, but actually if I draw like this, okay, it's not. So this, whatever angle it is making with this one, that is angle theta. So there is angle between area and this magnetic field. Area of this flux, sorry, surface and magnetic field. So EA cos theta. Make a note of it. Now this one was uniform surface. If it is non-uniform surface, area is not constant. So we will, what we do generally, remember 11th standard? You have studied something. If area is not constant, not uniform, how will measure, how will calculate that?
Integration.
By
Integration.
by integration. Integration means adding of it. So take all these areas individually, we can find it, or else we'll do integration with the limit of something. Suppose we have area of like this, magnetic field, electric field are passing through it. And one more thing, remember, whatever we are studying in this chapter, same thing ditto will study in magnetic chapter also. So get thorough with this one. If you're thorough with this one, you are thorough with magnetic chapter also. Ditto, same formula, same thing. Only a few things will change. Instead of charge here, we will have their magnetic field. Here, electric movement, their magnetic movement. Electric dipole, magnetic dipole. That's it. So if it is non-uniform here, so we can make it here D5 equals to E dA. Now dA is this small area. We'll take small area and we'll integrate for it. This is your dA, small area. This is the electric field. So phi equals to integration of E dA, or integration of E dA cos theta. So obviously E is common, also E is constant term, because we are integrating with respect to A. So this will be our formula. Flux is scalar quantity. So because of this formula, this flux varies from, if you see in this diagram, we can say it varies from minus EA and plus EA. Done writing? Shall I scroll? Kanuri, Ningraj, Ruturaj.
Yes, sir.
Yes, sir.
ठीक है, चलो. Next topic is your Gauss law. That is also very important. Gauss law is like very simple thing. Okay, just we need to know whatever we found your flux. Okay. So we found here like all this flux, it throughout all this surface, it will be similar. It will be similar to, or we can say 1 by epsilon naught times. So epsilon means what? Permittivity. If you remember what is permittivity? What is permittivity? One second, please. Oh, sorry, yeah. Okay, what I was saying, yeah. So Gauss law. So what is permittivity? Can you tell me? No, you don't remember?
This is the ratio of electric displacement by field intensity.
Electric displacement by
Field intensity.
field intensity. Okay. Any other simple definition or explanation? Okay.
Ability to store energy.
Ability to store any?
Energy within the material.
Yeah. We can say that, yes. Ability to store, we can say specifically potential. Whatever. But yeah, it's correct. Both are correct. Simple way it is ability to store. Okay. So here, net flux through a closed surface vacuum is equal to 1 by epsilon naught times that charge within surface. That means phi equals to Q by epsilon. And even previously we wrote here EDA cos theta or EDA dot product. That means these are charged particles. So what will I do? I'll take the small area as dA and as is closed Gaussian surface. See, Gaussian surface, like we can say simple words, let's some enclosed surface. But actually, see, this is imaginary, okay? It's not real actually. So we can write here a closed imaginary surface. Surface, which is around the charge. Let's write some points about it. Let's take first one. If there is a surface like something surface here, so let's take Q1. Q1, Q2 charge. Surface A, surface B. You can say S1. And some surface which is neutral charge or zero charge, S2. It is C. So let's write about this. Net electric flux in a closed surface. So this is all depending on charge inside. Depends on charge inside the surface. So in like we can say surface 1 S, which is Q by epsilon naught. S1 Q2 or Q1, whatever name we have, Q2 plus Q1 by epsilon naught. And S2 is 0 because no charge inside. So it's totally depend on how many charges are there, net charge. And electric flux depends on total charge inside the surface. So in first one, it is only Q1. Second one, we have Q1 and Q2. Third one, we don't have any charge, so it is 0. Now, the same way, if it is same way, it is like if I draw a charge here plus Q minus Q, so that is surface area named A. So net flux phi will be equals to 0 because Q will be plus Q minus Q. Net Q will be plus Q minus Q net by epsilon naught. So which is 0 by epsilon naught, which is 0. Understood? Guys, are you able to understand?
Yes, sir.
Okay. So we took inside charge. Let's take one point outside. If you're done writing, we'll take one more point, then only we'll end class. We'll take one more. Okay. Shall I scroll?
Yes,
Sure.
sir.
Now let's take some point Q charge and some area here outside this, and from the electric field lines are passing through it. So a point charge Q is located outside a closed surface S. So what we'll do here, we'll see how many number of field lines passing through that area. So number of field lines passing or entering also, okay, whatever you can say. S is equals to number of lines leaving surface. So net flux is 0. Condition is that no charge inside. Okay, are you playing?
No, sir. My family's.
Okay. I thought with the class you are also playing.
No, sir.
You can play, but after class. Okay. So number of lines leaving the surface will be 0 because in that surface itself no charge. Because in previous condition what we wrote, net flux is 0. Sorry, not this one, previous one. S2. There no charge inside, so flux is 0. So it will be same. It will be no change. That means 0 flux. Understood this one? Guys, these 3 points you understood?
Yes, sir.
Yes, sir.
Sir.
Okay, easy. Okay, so next class we'll have some application of this Gauss law. But tomorrow I won't be able to take class, and day after tomorrow also. No, day after tomorrow I'll try. Because I'll be traveling and I'll reach by 6 or something. I'll see that. I'll post it in a group. Okay, guys. See you day after tomorrow. For tomorrow, I'll give some work. You do it. 2 exercises I'll give. 30 questions today and tomorrow. Today 15, tomorrow 15. It's easy only. You can finish in half an hour itself. Okay, guys. Bye-bye.
Thank you, sir.
Thank you,
Thank
sir.
you,
Bye,
Thank you,
sir.
sir.
Bye-bye.